Hello, Bala.
Hi, Navya.
Have we started?
Not yet. I guess we are waiting for Tapsi. She's on board.
Okay. Rahul, can we begin? Hi, Vikalp. Good evening.
Hello, Tapsi. Very good evening.
Hi, Tapsi. Very good evening. Yes, we can begin, Tapsi.
Yeah, I'll hand it over to you, Prabhi.
Sure.
Hello. So should I start with the PPT?
Yes, please.
Yeah. So hello and good afternoon, everyone. I'm Sonit Gupta, and I would like to start the proceedings with a very warm welcome to each and every one of you.
Yes, Sonit.
Yeah.
So hello, everyone. Very good evening. So yes, guys. So you guys can start by presenting with your project. So Sonit, you can go first. You can share your screen and you can start.
Yeah. So so in today's session, we would be discussing about the roller coaster. Yeah. So we would be discussing about the roller coaster ride of our training, where we learned a lot of new skill sets that were essential for the DevOps point of view. And with the eagerness to learn a lot more and to showcase the same, we will be taking you through the project that we were assigned and our approach to it. So the agenda of today's meeting would be as follows. Next slide, please, Karthikeya. So first would be the introduction to the project and the explanation to the problem statement that we were assigned. And moving ahead, we have the high-level overview of the architecture of the source code, and then is the solution that we all worked out. And we would be providing you the detailed explanation of all the 3 different strategies that we constructed, and a working demo for each one of them, discussing their pros and cons. And at last, we would be having a look at the tech stack and the future scope and conclusion related to our project. So now here is our team who have put up their efforts to make this possible and make the project working. So let's begin with the introduction to the problem statement that we were given. So there is a company called Global Edify, which is currently using Azure Cloud as one of their platforms to host their product, which is called Voting App. And the app comprises of various modular components, which are built using different frameworks, tools, and developed using by different teams in various languages. And as the product evolves, we have different versions of the product as well as their components associated with it. So in order to facilitate easier multi-environment build and deployment, we had to provide a solution which had the following features. And first one is it should overcome the difficulties associated with the complex builds. And second one is the reduction in the manual effort required to build various components. Third one is it should open up the doors to incremental builds for various environments. And the last one is it should be able to cope up with the changes to the legacy build versions. And now I would like to, now Akshat will take over from here and will be discussing about the high-level architecture design of the source code and various strategies involved in our solution to it. Thank you.
Yeah, thanks, Wanit, for that. Good evening, everyone. I hope all of you are doing well. I am Akshat, and I'll proceed with the high-level design. Okay, so the high-level architecture demonstrates a complete end-to-end application constituting of both front-end and back-end applications. This is just a simple example of the various types of pieces and languages we might see and how to deal with them in Docker at a basic level. The backend application interface has been built using Python. The data component is using Redis. Python application uses Redis as the in-memory database to store cache or the metadata in order to provide ease of accessibility and attain minimal response time. The metadata in our case being the information of the user. Worker app is basically providing the functionality of adding or removing a user from the database. The .NET Worker application consumes votes and stores them in a Postgres database, which is backed by a Docker volume. The Postgres database captures new data. For example, if we have to register a new user. The front-end application interface is coded with Node.js, which shows the results of the voting in real time. Moving on to the next slide. Okay, so we were given the flexibility of having a DevOps environment of our own choosing. We had the freedom to choose any of the DevOps tools inside or outside of the ones that we were taught during the instructor-led sessions. But the overall agenda remained the same. We had to deploy the complete application on Azure servers. Each one of us worked on the project individually, and basically the solution strategies that we followed as a whole could be categorized as the ones mentioned. The first solution is the most basic but easy to follow solution, which uses Jenkins, Ansible, and Docker Compose. The second strategy includes Kubernetes as an orchestration tool. And in the third one, instead of using Jenkins, we're using Azure pipelines to build a project. Abhiram and Arnab will take up the first solution strategy next. Thank you.
Good evening, everyone. I'll be continuing in the first solution. So this solution basically consists of tools like Jenkins, Ansible, and Docker Compose for finally deploying the project. Yeah, next slide. This is the architecture of the first solution. So in this architecture, basically we are dividing the part into controller node and target node. So in the controller node, basically we are running the Ansible script for installing the tools which are required for the project, like Jenkins, Docker, and SonarQube. And we were initially given a source code, like the base source code for the project, and we used Git for maintaining the source code. And next, we linked the GitHub to the Jenkins via webhook, where if we push push any report to the GitHub, it basically runs the Jenkins pipelines. So Jenkins pipelines, we ran first. We check out to the GitHub code, and then we run the Sonar Cube, which is used for code quality analysis, and it basically consists of few of the rules specified, and it checks for bugs and vulnerabilities in the code. In the Jenkins pipeline, we also run the Docker Hub. So basically, we are pushing our project resources to the Docker Hub. So the next part of the architecture will be continued by Arnav.
Hello everyone, I'm Arnav. So yeah, as explained by Abhiram, we were right now in the controller node, and now we have to connect this controller node to our target node, which is the deployment side. So for that, in our Jenkins pipeline only, we are have configured Ansible in such a way that the controller node is SSHing into the target node, and once we have SSHed into the target node, there are basically two steps. First is we have to run Docker and Docker Compose in the target node. So for that, we have used an Ansible playbook so that we can automate the part where we can install and configure the Docker and Docker Compose. Now, steps remaining are, first we have to build the images. So for that, we are running the Docker file using Ansible, and the last part where we are using Docker Compose, it will pull all the images, and then we'll run all those containers. Yeah, in this way we have deployed our project into a target node from our controller node. Thanks. Now Kartikeya will show you the demo part. Over to you, Kartikeya.
Yes, hi everyone. So as Arnab and Abhiram have explained, I'll be taking you through the demo of the architecture that we just demonstrated. So basically, first we pushed all of our source code to a Git repository. And from that Git repository, here's where the actual architecture starts. So as you can see, we have a Jenkins pipeline here. Now, as mentioned by Abhiram and Arnab, Jenkins pipeline is triggered by a webhook. So essentially, whenever there is a push or a commit to the GitHub repository, the Jenkins pipeline is automatically triggered and the whole build goes through its phases. So all the phases mentioned here are that first it checks out the SCM, then it performs the Sonar Cube analysis to check the code quality. Then comes the part where we install Docker and Docker Compose. Further by the part where we build all the images using Docker files, and then finally we run Docker Compose to up the app. Now, what is to be noted in this architecture is that there are two nodes. First is the target node, which is used for running the pipeline as well as all the monitoring systems. So if you were to look at the IP address I'm highlighting, here we can see that this is the IP address of the control node. This node has all the Jenkins pipeline, Sonar Cube, and other monitoring tools. Now that I've mentioned Sonar Cube, we can see that on the exact same node, we also have the Sonar Cube monitoring station that checks the codes for bugs and code quality analysis and gives them to the developer so improvements and corrections can be made. After Sonar Cube, I'll actually show you the application that we have deployed. So if you were to look at the IP address, it's different from the previous two because this is the target node on which our application can be hosted. So this way our code gives the flexibility that even if we have a skeletal VM, we can just SSH into it using our target node. And once we do that, we can basically deploy our application on any machine that's available inside the organization, giving us a lot of flexibility. So as you can see, this is the voting application. This is deployed through Node. This is the IP it's hosted on. And the results of this very same application are hosted on the same IP address, just on a different port. So this is the overall demo for our application. Now, what will be happening is that Kushal will explain to you the use cases where this application comes in handy and where should we use this solution compared to the other two strategies.
Yeah, thank you. My name is Kushal, and here are a few use cases of the architecture proposed. To begin with, this architecture can mainly be used if our concentration lies on developing and testing simple applications. By the term simple applications, I mean that it is limited to the number of users who make use of this application and is not going to be vast in number. Also, if the company has a constraint on the number of resources it can use, then this is the option to go with, because the tools that are being made use of in this architecture are not very computationally intensive. Also, when there is a need to configure inter-container communication easily between the different services that are being made use of by the application, then since we have used Docker Compose, all these services run on one particular host or a cluster. So configuring the facilitation between containers is going to be very minimalistic. And since we are talking about simple applications, the scalability of such applications will not be too high. Docker Compose can maintain or handle such scalability up to a certain point, and beyond which we'll have to make other tools. We'll have to make use of other tools, but to a certain point, this architecture can be made use of. So that was about strategy 1, and strategy 2 will now be taken over by Kaushik.
Thank you, Kushal. I'll be continuing with strategy 2, where we use Jenkins, Ansible, and the Kubernetes orchestration platform for hosting our services. Moving on to the conceptualization of our strategy, Karthikeya. So we have our code on GitHub, which is our SCM for our architecture. Then on our development machine, we push our developed code, or what the developer pushes the code. And through webhooks, the Jenkins pipeline is triggered on its own. So the first step in the Jenkins pipeline is to run the code quality analysis on SonarQube. Moving on, a script is then triggered to build and push the images of our services to Docker Hub. Now moving on to the deployment side, we use Ansible playbooks to install and set up the Kubernetes and Docker services on the deployment machine. And then we use another Ansible playbook to deploy these services onto the Kubernetes cluster. Also, we do the same with Docker. We do the same deployments of Docker containers using Docker Compose. Here, because as we have two different setups, we can use one for production environment and one for test. And to monitor our whole setup, we use Grafana and Prometheus. Karthik will now explain the pipeline stages of our architecture.
Yeah, thank you, Kaushik. So basically, Jenkins is our total outer wrapper, which basically orchestrates the whole CI/CD pipeline. There are various stages within Jenkins, which makes the deployment possible. So I'll just show these stages one by one during our demo as well. So let me just share my screen. Yeah, so I hope my screen is visible. Yes. Yeah, right. So our setup 2 consists of 2 virtual machines, where one acts as a master node and the other acts as a controller node. So in the master node, we basically have our Jenkins, SonarQube, and Prometheus and Grafana running. And in the target node, we have our deployment applications that are being run. So this is our basic Jenkins pipeline. So as you can see, there are various stages within the pipeline. So first is our checkout SCM stage, where the code base from the repo is being pulled to the Jenkins workspace. Once that is done, a SonarQube performs a code quality analysis on this code which has been pulled from the repo. So as you can see here, so this is our SonarQube dashboard, which displays the bugs and other features which are there inside the code. As you can see, both Jenkins and SonarQube are being run on the master node right now. Right after the code quality analysis is being done, so we basically build containers out of the images. So we build images for the containers which are to be deployed. So that happens. So basically we build the containers for the voting app, the result app, as well as the .NET worker. So, and once the images are being built for the container, this is pushed to the Docker Hub repository for storage. So as you can see, this Docker Hub repository, which is being hosted, which has the images for the containers to be deployed. Right? Yeah. So the next stage in our pipeline is Ansible. So Ansible runs from the master node, and it controls all the configuration and deployment part in the target. So there is no intervention whatsoever to make any configuration changes in the target node. So first Ansible does the Docker installation and the Minikube installation on the target node, right? So that happens. Once the basic Docker and Minikube installations are done, the Kubernetes cluster is being deployed by the Ansible itself. Once the cluster has been deployed, to add on to redundancy, we have also done the same, bring up the application setup using Docker Compose as well. So we have both the application setup running on a Kubernetes cluster as well as on a Docker Compose deployment model. So as you can see here, this is our target node's terminal. You have your Kubernetes cluster deployments which are running, and the associated services to these deployments which are being run. And then we have our containers which are running, which was done using the Docker Compose, right? So as you can see, this is our end result page. Here you can see that this page was processed by our Kubernetes cluster. You can see the deployment name, right? The replica set hash followed by the pod hash, which is processing this request. And here we have a results page, so which is also being orchestrated by the Kubernetes cluster. And this is one another setup where this setup is being run by the Docker Compose, right? So this is just being processed by a Docker container, which is running loosely. So as we told you, we have also implemented our monitoring setup. So in our target node, we have our C advisor, right? And then node exporter, which is basically running to scrape the metrics and push it to Prometheus database. Yeah, so as you can see, yeah. So our Prometheus database is basically running on the target node. So the Prometheus database targets are the C advisor from the target VM and the node exporter, right? So this is the Grafana dashboard, which displays the data which has been scraped from the Prometheus database. So as you can see, this is the total number of Docker containers which are running on our target VM and the CPU memory usage of those two VMs. And this dashboard shows how much of resources is being utilized by the Kubernetes cluster. So this is specific to the Kubernetes cluster, which is running on the target VM. So one important fact of using this monitoring tool is that we can also configure alerts such that whenever our resource usage exceeds a limit, we can send alerts to the DevOps person so that they can scale down or provision more resources, which can be utilized to make sure that the application is running smoothly. Yeah, so over to Vasant to explain the benefits and features of the architecture which we follow. Thank you.
Yeah, thank you, Karthik, for that. So this wasn't here, and I'll be taking over the use cases for our proposed solution, or how our proposed solution exactly fits the problem statement. So starting with enabling working on distributed environments, as said, the Kubernetes provides us with an option to execute the target systems on clusters across various distributed environments, thus making it whenever the scaling is required, it makes it easy for the application to scale up and down. And also coming to the fail-safe replication, it is essentially another feature provided by the Kubernetes cluster, wherein the number of replicas can be configured for each and every individual containers, so that in case of any infrastructure maintenance problem, one container specifically at a site goes down, the others are still up and running, making sure there's a seamless experience for the user base. And coming to cross-platform portability and flexibility, and the prompt statement said that the company as of now plans to execute and go with the Azure cloud model, but assuming like the proposal that we did, they have an on-premise server that has only for a pre-production environment kind of thing, where they want to just stage the application and test. In that case, they could easily make the Kubernetes same code to apply over there also. It is cross-platform compatible, so thus making it less changes required. And coming to the orchestration tool with load balance services, the very fact that Kubernetes is an orchestration tool with load balancer for microservices makes it a potential client for usage under this kind of applications, wherein we have 5 different component individual containers that are running separately, but are initially connected to them with a single central Kubernetes API cluster. So that's for the use cases. Yeah. Go to next slide. Yeah, so here are a few assumptions that we did during our proposal of the solution. One thing is that while we made the entire CI/CD pipeline possible, we did it under the assumption that the testing phase has already been done. So essentially, in actual state, once the continuous integration stage is completed, the QA team will do their rigorous testing, and following that, they will be pushing it into the actual production environment. But for our use case in the project, we assume that the code that is being pushed is already tested and validated, and hence it can be directly pushed into the production environment. This is a small assumption that we did during our project. And now over to Nikhil for the third strategic solution.
Thank you, Vasant. Good evening, everyone. Wait, I think, yeah. Good evening, everyone. This is Nikhil. I'll be walking you through the third strategy we have adopted. Here we have used the Azure DevOps and as well as used the Docker as well as Kubernetes. So our objective in using the Azure DevOps was we wanted to create a common workspace for everything. So instead of having a platform for source code management and another for running the pipeline, we wanted to make use of the services that Azure provides us to create this architecture.
So from the bottom left, we have the project running on our local machine, and we use Azure repo to store the store the source code. And from there, we are using Azure pipeline to deploy the pipelines. We are making use of two VMs. The first one contains the Docker and Docker Compose, where we run the project using containers. The second one contains a Kubernetes. So we are using a cluster to deploy here. In both the pipelines, we have configured Ansible playbooks. So for each playbook, there are two playbooks essentially in each pipeline. The first one is used to set up the environment. For example, for the first pipeline, we are setting up the Docker environment, and then in the second playbook, we are running the commands for starting the containers. In the second playbook, we essentially set up Minikube and kubectl, and we start the deployments in the second playbook. So after that, we have also set up SonarQube, which is essentially for code quality analysis, and it is also being deployed in a container. We'll see more about this in detail in the demo, which will be taken by Akshat. Thank you.
Thanks, Nikhil. I will be taking you through the demo of both the pipelines which we executed. So this is the GitHub repo where there was one master branch and there's a separate branch for our developments. So yeah, so this is the pipeline script which we made use of, like developed it, and this is a pipeline where we executed. And these are the different stages, like the SonarQube analysis and the building Docker images, running the containers on the VM, target VM, etc. So and also this is the second pipeline which Nikhil just explained, which uses Docker Compose. Sorry, which uses Kubernetes to deploy the pods and servers on the VM. Yeah, so the difference between both these pipelines was here we have used Docker Compose to deploy, and here we have used Kubernetes to orchestrate and deploy the services, right? And yeah, like everyone else have included SonarQube. Here's the SonarQube dashboard, which analyzes our codes and gives information about our code smells and code errors and vulnerabilities, etc. And so this is the application hosted on the target VM, and this is the result app, which shows the results of the votes. So as you can see, when I vote on dog, the vote percentage changes, and anyone can access it right now. So you can vote and just change the percentage over here. And yeah, also Docker Hub images which we pushed were are stored in our repositories, private repositories in Docker Hub. So that's how we executed this program, this application with two different pipelines. So we can use one pipeline for testing environment and another for the production environment. So now Karthikeya will take over the use case of our architecture.
Yeah, so coming to the use cases and the main features of our strategy. So the main component of our strategy is Azure DevOps. Now, Azure DevOps is a kind of software as a service, which provides an end-to-end DevOps toolchain for developing and deploying software. Now, some of its main features are: first, it can be easily integrated with existing on-premise infrastructure. It can also be combined with any other third-party tools like Docker and the Kubernetes. Second, it is designed to work on any platform like Linux, Mac OS, or Windows, or with any language like Node.js, Python, Java, PHP. Third, since it is a software as a service, we don't need to worry about the patching and upgrading the toolchain manually. And fourth, it also enables us to provide a continuous delivery to other cloud platforms such as Google Cloud Platform or AWS as well. Now, Arnab will be explaining the technology stack of all three strategies. Thank you.
Hello, everyone. So basically, this is the list of all the technology we have used in our projects. Our different strategies have used different tools. So as explained, in Codebase, we are using Python, .NET, and Node.js. And as a database, we are using PostgreSQL and in-memory database for as Redis. And yeah, so in infrastructure, we have used Ansible for automation and Docker Compose and Docker for containerization and like container orchestration, we have used Kubernetes, and like in execution pipeline, we have used Azure repos, Azure VMs, and GitHub also. And for creating pipeline, Jenkins and Azure DevOps. And as for testing, we have also used SonarQubes. Now, over to you, Karthikeya.
Yeah, hi guys. So Karthikeya here. So now I'll just do a conclusion. So the reason we showed 3 use cases here is that to go beyond just the technical aspects of it and see which use case is suitable for this organization depending on what stage they are in. Because like we'll always have multiple correct answers to the same problem. So it's just about picking the answer that's most suitable. So in this case, our conclusion was that for the first approach, that is Jenkins, Ansible, and Docker Compose, we should use this approach if we are trying to develop only simple applications and the team is relatively inexperienced. So there are no people with extensive Kubernetes knowledge. There are no people who are specialized in that field. And also the scaling requirements are low. So as it was highlighted by Kushal that it doesn't need to scale to a lot of people. So Docker Swarm should be just enough. The second is in the second approach for Jenkins, Ansible, and Kubernetes. Here we should use this approach if we are developing the application with a very experienced team. And we require high scalability and security in the long term. Because as we all know, Kubernetes has an excellent capability to scale on demand for a large number of users. Kubernetes pods also provide additional security, which is always good for a company in the long term. The third approach is the Azure DevOps plus Docker Kubernetes approach. In our problem statement, it was mentioned that the company already uses Azure VMs. So it makes sense that there is on-premise infrastructure integration. They can go further deeper into the Azure integration ecosystem. And as we all know, Azure comes with a lot of patching services, support of the Azure cloud team, and all those other services, which are extremely useful for the organization. And as it mentioned, like we're trying to migrate a few applications and make complex builds easier. So Azure DevOps pipeline also helps with that. Now talking about the future scope, we think we can add some traffic management instruments such as Elastic IP, load balancers, multiple servers, and hosting domain for the voting application. Currently, it's hosted on single IP addresses and particular ports, but we can probably register a domain to it, add load balancers via Kubernetes, etc. And also use Elastic IP so that it doesn't change. Then comes the fact about including monitoring systems. It was already done in the second approach in some capacity, so we just plan to expand onto that. Furthermore, we'd also try to include the testing pipeline in the same pipeline. So basically, we can have a testing environment and a production environment running side by side. Yeah, and that's our conclusion to this project and all the 3 strategies we've taken. Thank you.
Before we conclude, I just wanted to mention that since Karthikeya said we are using on-premise infrastructure, we have even used the Azure Dev Boards feature to plan our project properly, and then one by one finish all the tasks and then execute the project. Yeah, so I just wanted to mention this one thing.
Yeah, absolutely. To echo what Akshat said, like we did a proper planning and organization before we got to the coding and implementation part. That's how we were able to find these 3 strategies, and that's how we decided, okay, which one is applicable in which use case. Yeah, that's it. So open to questions from all.
And thank you, guys. I'm Vikalp. Let me first introduce myself. I am Vikalp, and I am working with Amadeus for like 7+ years now. And thanks a lot, first of all, for a very nice presentation to all of you, and definitely the approaches, the strategies that you took really good, and the different technologies that you used, and which was really nice. Okay, so good work. So first of all, I would like to know from you guys, was it fun doing this project?
Yeah, we definitely got to learn a lot of the theory and apply it. So it was very easy to just listen, okay, this is how this thing works. But when we were applying, there was a lot of errors, troubleshooting. So I think that was a good learning experience.
Yeah, but my question was more, did you enjoy it?
Yes, of course, Vikalp, we did enjoy it. As long as there is some part of learning is happening, I think there's bound to be, like, you're looking forward to it, and we did enjoy it. I think when I say that, I speak for the whole team.
Awesome.
Yeah, Kaushik, it was executing this project was a lot of fun. Like getting exposed to these new technologies was very good. Yeah.
And before you guys started with the training, did you know about any of these technology?
Very barely. I mean, no, definitely not enough to do the project. So I think the training definitely helped. Yeah.
Yeah, I guess generally in our college phases, we are more exposed to the development side of things, but not much to the development side and how these applications are actually running behind the scenes, right? So that is the big mystery which happens within the companies. How companies orchestrate that is the massive selling point for each company, right? So getting to know that and executing an end-to-end deployment of a product, I guess, was the biggest experience which we had and the learning assets. So that was a great takeaway for us.
Oh, very nice. Happy to hear that. And what was the most challenging thing in this full project that you think?
I guess we had a lot of different tools, right? So we learning each tool itself would take a lot of effort, like and integrating all these tools into a single pipeline as such and making it all work, I guess, was the toughest thing. Like each service works properly. Once you start integrating these service various different tools, you start experiencing errors and bugs, etc. So solving that was, I guess, the biggest hurdle which we faced and the most learning which we got from the project.
Yeah, and I think that is what DevOps is all about. So yeah, it was learning all the troubleshooting was also a big part in the project. Yeah.
Yeah, absolutely. To add on to Akshat, just keeping track of all the solutions we've tried and what their implications are. So that was a really nice experience in troubleshooting. And also, if you had to pick a specific tools, I think Kubernetes was quite a challenge, trying to understand all the configs, port forwarding, all those things. Yeah.
Good. And apart from the technical challenges, I would like to see were there any other challenges that you felt? And I see there were 3 strategies, so you must be working as 3 different teams, or how did you organize yourselves?
Of course, with the current situation here, we are always stuck at home. The collaboration part, of course, is hampered. But we did work individually. We collaborated when we had doubts. But overall, out of all our solutions, a lot of them had similarities. So we then ended up into 3 of them. We could put ourselves into 3 groups in such a way that our solutions fit those strategies.
Yeah. No, my question was more in terms of I think if I'm not mistaken, you are 13 or 14 of you, right?
Yeah, we're 11 of us. Yeah.
11 of you, right? And so how did you decide that who will work on strategy 1, who will work on 2, who will work on 3?
As I mentioned, it was individual at start. Like all of us started conceptualizing our workflow, our architecture for the end-to-end deployment. And then as we moved on, we realized that few of us have a similar approach to it. So then we started grouping ourselves into them. And then a particular group, like people with the same architecture, would collaborate to understand how one person solved a particular error or a bug in their system. So more or less, the project as a whole was individual, but then towards the end, we started collaborating to achieve the goal.
Yeah, just as I showed in the Azure repo, all of us had different branches, and everyone has a different, almost different solutions. We just collaborated we just clustered it into 3 solutions for the demo.
Nice. So it wasn't like 3 members or 4 members per team working on a strategy. It was each of these 3 to 4 members implemented the whole CI/CD pipeline by themselves. And since our ideals were similar, we presented it as a team. So even it's not that 3 to 4 people worked on a single pipeline. Each and every one of the 11 people worked on their own pipelines. And since our strategies were similar, we collaborated during our doubt sessions in Excel.
Perfect. That is really nice. So coming to this, why do you think that what does these technologies like Docker, Kubernetes, or Ansible, what is the problem they are simplifying?
So as I said, as like Docker simplifies a very big problem. Like since a lot of applications need different dependencies, different environments to run. What Docker does is it containerizes the application and makes it ready to deploy anywhere in any environment. So Docker solves that problem. And then Kubernetes also, like say if a multi-container application is required, Kubernetes is very useful to orchestrate all the processes and containers.
Yeah, that's not all. During my project execution, I actually had a problem with the VM. So like for the first 2 days, I worked on a pipeline and set up all the Docker environment and everything. And like on the third day, the connection to the VM was refused. So I wasn't sure what the exact problem was. So I had to stop and start. I was like devastated that I had to do the whole thing again. So then I just remembered that I had the pipeline. Like all I had to do was just change the username. I mean the host name and give it the new URL. And when I run the pipeline, like it was as if it's the same platform, like the same VM I had used. Like there was little to no modifications required. So like configuring such a pipeline was like, I think it would be a lot more helpful.
Yeah, so what Nikhil's trying to say is basically plug and play viability, right? So if you want to scale up or deploy it in a new setup environment, you don't need to do the processes manually. You already have your pipelines and already set up. So you just make a few config changes and you're good to go and deploy it in a new setup as well. So that is the main, I guess, feature that the whole environment brings to the setup.
And also to add on to that, I guess the reduction of manual intervention, I think two main issues. One is the collaboration and the second is reducing manual effort as much as possible. So I think everyone's already covered the collaboration element. It's easier to distribute, environment is simpler, plug and play. Reduction of manual infrastructure is thus that I don't need to now run 15 commands, remember 15 commands, plug them in the terminal and get errors. I can just have a simple Ansible file that does all of that for me. It tells me if something's going wrong, and I guess that significantly reduces the time it consumes to do repeatable processes. That if tomorrow I need a VM with this configuration, I can have it in 30 seconds as opposed to someone sitting and configuring it for 30 minutes. And I think that's a good help for DevOps technologies.
Vikalp, you are speaking on mute.
Sorry, Varga. Thank you. So can one of you tell me what do you exactly mean by DevOps? Anyone? I mean, see, there is no right wrong answer. Just give it a shot.
Yeah, I think DevOps means bringing together the development and the operations team together, right? So they can collaborate much more effectively and efficiently. Like in usual software flow, like software building flow, like a traditional waterfall model, there's always a gap between the developers and the operations team. But with this DevOps method, it's easy for the development and operations team to work together efficiently.
And why they need to work together?
So that it took a lesser time for the deployment and the delivery of the product ultimately.
Okay.
Yes, so like there's CI/CD, continuous integration and continuous development. So like the gap between the developer and testers QA is reduced so that we can increase the reliability of the product. Also, like continuously the developer is pushing their new codes and it's being tested at that moment only. Yeah, so it increases the reliability and effectiveness of the product.
Okay.
I guess it's more about promoting transparency. Like if you take a big organization, there are development teams and operation teams. So there is basically a barrier between development teams and operation teams. Like the operations teams don't know the constraints on which the development teams are working on, and the development teams don't know the constraints on which the operation teams are working on. Right. So DevOps basically tries to integrate or break that barrier so that there's a transparency onto the whole requirements, so that the how do I say, the setup can be made from the initial stage so that the requirements and constraints of both the development team and operations teams are built into the foundation, so that once the project moves on to the later stage, there is no conflict between these two. So basically, you have a higher flexibility and transparency on what each team is working on. So that's the core concept, I guess, DevOps brings to the table.
Very nice. You all you guys are touching very valid points. Anybody who has not spoken till now would like to add something?
Yeah, so during our instructor sessions, our instructor gave us a use case also, right? So he told us that in the previous scenarios and the legacy scenarios, it used to take almost 2 months to deploy an application. So right, the developers push the code and then it moves to testing stage and then production stage, right? After DevOps came into picture, everything was moving together, right? So it became easy, and it took almost like 7 days of time, reduced the time from 2 months to 7 days for deploying a service, right? So DevOps bring that into the picture.
Very nice. Yep, very true. So is DevOps a technology?
It is more of a culture or a philosophy, I believe, more on those lines. So it essentially it doesn't have a conventionally defined role that this person has to do this job, unlike a software developer or such. He needs to know this language and stuff. He needs to bring in and communicate and enhance with all the teams to make sure that the organization becomes more efficient than it already was by automating all the jobs wherever possible.
Oh, very nice, Vasant. Very nice, guys. Good, well done. Bhargav, Debashish, feel free to jump in if you have anything.
Yep. Good work on presentation. So basically I want to ask on the strategy, do you also consider Docker Swarm, and why you choose Kubernetes if you consider Docker Swarm? Anyone?
If my understanding is correct, in strategy 2, while I didn't directly work on it, the aim of strategy 2 was to build something that's long-term scalable and something that's more secure. When we just read about it and researched about it, it came across as that Docker Swarm does not scale as well as Kubernetes. So I guess that was probably one of the reasons why we picked Kubernetes over Docker Swarm.
Any other points? Or this is the only consideration?
Also, I think the maintenance and support for Docker Swarm isn't going on a consistent manner as of now.
Okay. And you are having, we're having only one VM running for the deployment. So why you need a Kubernetes cluster for it?
Yeah, that resource constraint was due to the Azure free trial. We only had free trial, so we just had the whole deployment node running on a single VM. So if we had been able to give multiple VMs per provision to us, I guess we could have deployed each of these services on different nodes. So that was a physical resource constraint. So we just resorted to doing all the microservice deployments on a single node.
Okay. And how are you installing Python in the Docker image? Or how are you configuring Python in the runtime environment?
So we were given the source code of all the three apps: the vote app, the worker app, and the result app. So we were given the Docker file to build the image. So we just build those images and push it to our repositories. That's what we followed.
But to run the application, you need, you need Python, Node.js, and including the DB modules.
That's what Docker solves. All the content and the configuration, the dependencies are inside a image. So we do not need to explicitly set up a environment for each and application. Like it's inside the image.
So how Docker knows that what are required for your application?
It's inside the Docker file. We build an image from existing a Python based image. We're building an image from an existing Python image. So
Okay. Yeah. Main thing is, I mean, you've understood how the Docker file and what you have to write in that. And
yeah,
I mean, application deployment is one thing, but what dependencies it needs to run, what modules it requires, and runtime it matters, right? You should know how do we define whichever modules required for your application.
Yeah, it is mentioned in the Docker files which we use. I'll just show it to you. Yeah.
Okay.
So it
What is
uses
requirement.txt? Can we add any of the modules inside it?
sorry, what?
Yeah, we can always modify a requirements file based on the current requirement. So as and when the requirements increase, we can always add them here, and Docker will take care of packaging it into the image.
Can you open Docker file again? Yeah.
So it adds the requirements txt file in.
Pip install. How do you know how pip works and what has to be configured at the runtime before pip works before using pip? I mean these are more technical, but do you have a basic idea what is pip and how this installation works?
Pip is a package installer for Python, I guess, and to run pip, we all need to have a prerequisite as a Python some version 302 and pip itself.
Yes. And expose 80. I mean, what does this line mean?
It's the HTTP port, right? So it exposes that port.
So if you have to make it HTTPS, how it works?
If I'm not wrong, right now, since we're just hosting it on a local Azure VM, there's no certificate associated with it. So I don't think an HTTPS connection would be successful. But while I was going through Azure services, I found that there are provisions to host it on HTTPS certified Azure URLs. Like it just costs extra resources. I don't think we had that option in the free tier. But if we can configure that certificate, then we should be able to host them as HTTPS.
Good. And one more question. I mean, this Docker file, you are configuring Python and required modules of Python, but you are using Node.js. I mean, AngularJS or Node.js scripts as well, right? So
yeah, Node.js is for the worker file, so that has a separate Docker file.
Okay.
Hi guys, I have just one question. First of all, great presentation, and I think many of the interesting points covered already by Vikalp and Bhargav. So if you can come back to the Docker file, I just have one question there. Yeah.
Which Docker file?
Yeah, this is the one. So it's any generic one. So say line number 19. Why didn't you use entry point? Why did you use CMD? Or do you know what entry point does in Docker file? Give it a shot. It's okay if it goes wrong.
I don't know what entry point is, I think, but these are the artifacts which is.
I think, as far as I know, I mean, like when we use CMD command, we can, override the commands inside the container. But if we use entry point, we cannot override the commands. Like we cannot give any external command inside the container.
That's partially correct. Okay, entry point also can be modified using
basically your starting point to your container. So from where your containers start and begins. So that I guess you can specify as entry point. So CMD is just commands you run. So entry point is basically how you get into the container and which is the application or the service which runs first. So that could be defined as an entry point.
Okay, good. So coming to artifacts, all these Maven artifacts, did you use some artifact repository to store it, or how did you maintain them? Or this was in local machine?
No, the artifacts were not stored. As we showcased, only the Docker images were stored where the Docker hub is. These artifacts are still within the container. The artifacts were not stored.
Okay, sure. Bhargav, please go on. My questions I asked.
Okay. Just one question on this file. See, can't we just remove this CMD and put entry point and it will work? Will it or will it not?
I think entry point is predominantly used when your package is run as an executable and not when we.
Sorry, Karthik, but I'm not sure if voice was breaking for me only or.
It's for all.
No, we couldn't hear him actually. Repeat, Karthik or Kaushik, anybody?
Can you hear me now?
Yes.
Yeah.
I feel that when we use entry point, the package is essentially run as an executable and not when you deploy it onto a server. That is my understanding, but I think I could be wrong there.
That was a safe answer, no? That's fine, guys. You can explore it. Means the thing is, I think the point which is being made here is good to when you are putting some. Means I think this Docker file is like if you say it's the most important file. So at least, and it's a very simple and very basic file. If you see very few here, if you see keywords that are used there. So we should understand like each and every, at least that much, we should try to get as much knowledge as possible on those things. Why we are putting, if you are writing add, why you are writing add, why means because you created a work directory, well, very good, but because is it because everywhere you saw in the Docker file, okay, create work directory like this, or there is some reasons why we put like this. So those kind of answers, always question those things, the why part, why we are doing like this. And that is something which is going to help you to gain more knowledge.
Yeah, though it's a one-time activity, it's very important what we do. So the resources required for runtime, I mean, it should be optimal. We should not have so many resources, unnecessary things, or we should not have less resources. In any way, it will not work. And the importance of these commands is like, I mean, as I told, this is one-time part, but this is very important because this makes sure that application works with proper required resources, and there is no wastage of any resources or anything like that. You also know about dependencies of the real application. I mean, in the traditional applications, when we do something, deploy on Linux or some other VMs, you know, I mean, what you have to configure because there are kind of manually you install Python, you install JS or Node modules, you configure pip, or you may even configure the port forwarding or port opening, all these things manual. But here there is technology that taking care of all these things. But I mean, if we are aware of how it works, it will be more useful. So we know the application end to end.
Very valid point, Bhargav. And did you guys also like explore the code review part of it or the code maintainability part of it? What I mean to say is when one person, one of your colleague is writing that code, before you check in, did someone else review it, or it is just whatever you wrote in the first time, you just went ahead with it?
So since everyone said it's an individual project, right? So we didn't really get our code reviewed by our colleagues or anything.
Okay, and what about commenting the code? Like whatever code you have written, did you try to because this becomes very important when you're writing a production code. I mean, in this case, I understand, but when you are going for and writing a production code, be it maintainability and be the code review of what other person is writing also plays a very key role. Yeah, and it may not be always the case that person who has written the code will always be there. And I mean, sometimes these codes will be run in production for years, right? So keeping comments also is very important so that you can understand others' code, and the same goes for other person, whatever code has been written.
Yeah, definitely. And one of the steps we took towards this was primarily the documentation part. Since there are a lot of manual commands that are to be run, we tried to document everything that we were doing so that if someone else has to troubleshoot, they'll know exactly what has been done so far. And we also added we added a few comments, so we could probably extend upon that in future versions.
Sure, very good. Thank you.
And can you show us any of the Ansible files that you wrote, playbooks basically?
Yeah, sure. So this is the Ansible file. Sorry, not.
I think Azure Docker is a.
Yeah, this is mine. Yeah. So this is for installing of the Docker in the target node or the target VM. Do you want to see something specific in this?
No, nothing specific. I just wanted to see how you guys put through it and the organization of your YAML file. So some things which I think Devashish also put out there and Bhargav also, although these are very self-explanatory, but sometimes it's really a good practice to give some good comments out there.
Yeah, because those are good suggestions. We'll extend upon it and try to implement it.
Yeah, I mean, see, these are the learnings you do, and as you grow, you will keep on learning, right? So good practices, standards that you have to keep learning at every point of time. Can you scroll down a bit more? So when okay, we saw all the good things about this and all the good technology that you guys used. Did you give it a thought if something goes wrong, how will you handle, say your automation, this full pipeline is there, right? And you put this pipeline in place and then a developer pushes the code and it has to be deployed and it fails. How your system will recover? Did you guys give thought on those lines?
Yeah, so basically we can configure email notifications or the notification into the Jenkins pipeline as such. So that when our build fails, the post actions would be to send a notification to the DevOps person that the build has failed with these conditions. So that could be a notification.
And Azure already does that. Like whenever your build fails, it sends an email to the respective email IDs.
No, that is more of say I'm more looking in terms of self-healing capabilities, not in terms of intimation. How or you mail comes, how will you see where the problem lies? What will be your approach? How will you do those steps?
I speak only with respect to Ansible, but in Ansible, while I was searching, we were able to find a few statements that keep trying a certain action. So for example, if the server buffer is already full, the VM I'm trying to log in, so I can try it n number of times before it finally declares it as a failure. So if the first request got rejected because of too much traffic, like the second request would probably go through something like that. That was probably kind of self-healing. I think other than that, there's the monitoring systems that we probably want to implement in the future. Maybe that could be something like a Grafana or a Prometheus, so that we can see someone can keep checking it periodically to see if everything's running up.
Adding on to that, we also had logs which are being created inside our Ansible script. So we basically store the debug messages, register the messages that are being output after each task. And we also had a log functionality in our pipeline, wherein the whole execution is documented, and we have a log as such on the VM to see which stage has gone wrong. So that is there. And I guess regarding the deployment, Kubernetes takes care of the self-healing. Right? If one of the pod goes down, so that was the main point between doing it via Docker Compose or a naive Docker deployment compared to Kubernetes. Right? So Kubernetes takes care of that. Whenever one pod goes down, it immediately gets up another pod running. so that there is high availability as such. Yeah, regarding Ansible, we do have the log files that are being generated and are stored when an Ansible module is being run. So that from there we can.
Okay, very good. So for the logs of your pipe, you are creating it. You are keeping it in your VM. Yeah. I saw, I think in your presentation somewhere you talked about Grafana, Prometheus as well. I'm not sure if it was future development or something you guys put in place now itself.
No, we do have. So the node exporters runs on the target node, right? The Grafana and the Prometheus databases are on the master node. So even if something, the deployment container goes down, the Prometheus and Grafana basically are running on the master node, so that would not be a problem.
And so you are aware of the concepts of exporters and what they do?
Yeah. So node exporter is the one which basically gets your metrics, like the resource metrics, and which exports it to your Prometheus database. So from the Prometheus database, your Grafana is basically a user interface, right? So it creates the dashboard from the Prometheus database, and it shows you the statistics as such.
Very nice, Karthik. Good, very nice. Yeah, so I think whenever we do say enterprise level solution, one of the important things that we always consider is the fail scenarios. What if it fails? So whenever like you are having strategies when you defined, so one of the points you should always consider is the failure points. What are your points of failure? Then you minimize, okay, I minimize the points of failure. And if there is a failure at all, how your system will behave, how resilient it is. So those are all one or other. So means when I take system, it's not only about the software that you deploy, but your automation pipelines that you have in place and all the things. So these are some things you should like think when you are building or doing any project or delivering. Yeah.
Yeah, those are some good points. We'll keep those in mind the next time or maybe in this version. We'll keep those points in mind, yeah.
Yeah, as you start working in the projects and all those things, you will get a lot of learning. So the only suggestion from my side will be go beyond the syntax. Don't try to learn the syntax. Try to learn the semantics and why of the things, why some things work like this, and try to understand the architecture of few things, because syntax you will learn very fast. But if you understand why of different things, like why Kubernetes, why Docker, and then how the architecture of Kubernetes, what is the design of Docker containers, or Docker, how it works, that is going to build a lot of knowledge and help you to build yourself as with a good career and a strong expertise in the technical area. And while you work on these automation and all these things, definitely ensure that there is a programming language, and it can be any programming language, Java, C, C++, Python, JavaScript, Golang, whatever you feel good, that you have a good grasp and command over one of the programming languages. So if you keep this, and this is the learning time, you can start and just have all these things in place. And yep, those are, and personally, I very much liked the project and the way you guys did. And trust me, if now I look at you guys and I feel a bit embarrassed about myself that, okay, these guys fresh out of college are doing this after. And I took me around more than 14 years to come to these technologies. So, right, Bhargav?
Yeah, correct. Yeah. We learned something else and we're working on something else.
Yeah, so feel proud about yourselves and just say that this is the beginning, just a beginning, and these are the starting points, and you have a lot of pointers here for you. And from here, just begin your journey. That's what I can say.
I think Vikalp, we missed a very important point as a team. I think we as a team would like to thank our trainer Bala. He helped us through the project immensely with all that we need. He taught us everything. He helped us with our doubts and our issues. I think something as a team we missed here to extend our gratitude to him.
Yeah, especially was very patient with our doubts and errors. So that was the critical point for us to learn a lot of stuff. I guess Bala deserves a really good appreciation for that.
Good.
Nice.
Yeah, we can see in your work. I mean, so you don't know much about Docker Kubernetes before. I mean, after out of college, but now you know. You can even explain the strategy how it works. So that's not that easy in 1 or 2 months to train on these topics. And these are kind of latest technologies like Azure, Docker Kubernetes, including the Jenkins pipeline. So these are used in industry wide. So nice learnings. Good.
All right. Well, thank you so much. Thank you everyone for your time and your efforts into this entire program. The trainer, the trainees, as well as SMEs for helping us keep a check on the learning and also helping them and guiding them to the right direction. Thank you all so very much. Well, since today was the last day of all of your trainings, I welcome all of you GETs to Amadeus officially. I know you all are onboarded, but I guess from tomorrow onwards, you will have meetings arranged with your buddies, with your managers, etc. So all the very best for that. You will also see me sometime next week when you will be invited for an induction program. So all the best. And if there is absolutely anything that you would require my help with, I would be more than happy to help you out with that.
Yeah. So welcome on board, guys, and we are very happy to have you. And if you have any questions at this point of time, feel free that we can help with.
Welcome on board to Amadeus and for your career journey.
Yeah, welcome and all the best. I guess that's it, Kavya.
Okay, well, thank you. Thank you, everyone. Have a good day. Bye-bye.
Thank you.
Thank you. Thank you for your warm welcome.
Thank you.
Thank you.
Thanks, everyone.
Thank you, everyone.